This is the problem that I chose. A 3 kilogram toy car sits at the highest point of a 13-meter high hill. The car is gently pushed forward until it begins to roll down the slope. Assuming the car coasts freely without any friction or air resistance, how much kinetic energy and potential energy will it have at each of the indicated points? So this question involves calculating the potential and kinetic energy at these 4 points along the toy car's motion. There's no friction, so all the energy is conserved, so the total mechanic energy doesn't change at all. I chose this problem because being able to solve it would show mastery of the fundamental concept of this chapter, which is conservation of energy. The only forces acting on this car while it's moving is the force of gravity. So at any point, it would just be the normal force and the gravity. And at these points where it's on flat land, the normal force and the gravity are both perpendicular to the displacement of the toy car. So there's no change in the energy at these like flat parts. And when the energy is changing, the normal force is perpendicular, but the force of gravity isn't. So the only force you have to pay attention to is gravity. So the equation that we'd be using to solve this is just work is equal to force times displacement. The work due to gravity done on the object is negative gravity times height. And then the same thing for the potential energy due to gravity, the mass times the force of gravity times height. And so what you do first is figure out how much potential energy the car has at its highest point. So that would be right here. So you would just take this equation, you would put U gravity times the mass, which is equals the mass, 3 kilograms times 10 meters per second squared times the height, which is 13 meters. And then the answer you get for that would be the potential energy. And since this is at the highest point, there's and it's not moving at this point right here, there's kinetic energy is equal to 0. And then what you would do next is you would probably do this one. Their height is equal to 0 right here. So that means that there's no potential energy. And if you use this equation, you would find out that the kinetic energy at the lowest, well, height equals 0, is equal to the potential energy at the highest point. So for here, you'd have delta K is equal to negative delta U of gravity. So since all of the potential energy has been turned into kinetic energy, you would just take the answer from this one and you would put it here. And then for these two, what you would do is you would use the gravitational potential energy equation to figure out how much potential energy it has at this specific point. So 3 kilograms times 10 meters per second squared times the height of 2 meters. And the answer you get at this point, you would subtract it from the total mechanical energy, which you would get from how much potential energy it has at the highest point. Subtract it to get how much kinetic energy it has here. And you would use the same equation for this point.